So, a very good afternoon to all of you. Hope you are all fine at your places. Today, we will discuss about the frame design of the transformer. Now, this frame design of the transformer is, you can say that, the third part of the design. Earlier, in the first part, we are discussing about the main dimensions, or called as the overall dimensions, or sometimes it is called as the magnetic frame. If you remember, when we start the design of overall dimensions, or you can say that the magnetic frame, we are discussing about some important things that cover under main dimensions. And these are, first of all, we have to calculate its EMF per turn. Then we have to calculate the flux. After that, we have calculate its net iron area. Then we have gross core area. After that, we are calculating AW, that is called as the window area. And after that, we were split this window area into two components, that is height of the window and width of the window. And thereafter, we can calculate area of the yoke. So all these calculations are under the main dimensions or the overall dimensions, or you can say that the magnetic frame design. After completing this magnetic frame of design or the overall dimensions, we will start about the design of the winding. And in case of winding design, what we have covered what are the number of turns on the low voltage side, what are the number of turns on the high voltage side, and how these low voltage turns and high voltage turns can be calculated. After that, we are calculated the current on the low voltage side and the current on the high voltage side. And also we can calculate the area of the low voltage winding and the area of the high voltage winding. One of the most important concept that we had discussed in winding design, that if the area of the winding is less than 5 square, we can use a circular conductor. But if the area of the winding is greater than 5 square, we use a rectangular conductor. So whenever we use a circular conductor, in that case, we are calculating the diameter of that circular conductor by certain formula. So these all topics we had covered in my previous lectures. Now today, coming to the next part, now we are designing here the frame design, that once this transformer can be made, this transformer can be put inside a certain, you can say that, a frame. And what is the overall dimensions of this frame, what are the, you can say that, how the frame can be calculated. And you can see on the screen that is, in frame design there are only the two important thing, that is called as length of the frame, and W is W, and another is called as the height of the frame, or something called as the width of the frame. So you can see on your screen, the frame design consists of only the two components. That is, first of all, you can say that, that is the length of the frame, which is denoted by this W. And second will be basically called as your, and second will be basically called as your height of the frame, which is denoted by this H. Clear? Now in the frame design, we see how this width of the frame, or the length of the frame, and the height of the frame can be calculated. Clear? Now first of all, for calculating the length of the frame, and this length of the frame is denoted by W. Mind it, there is another term, that is WW. WW means width of the window, but only W means that is the length of the frame. And this length of the frame is equal to capital D plus A. This capital D is distance between the two core centers, and the formula is capital D is equal to small a plus WW. Clear? Now here, the WW, that is called as width of the window, this value you had already calculated in previous. जब आप लोग अपना मेन डायमेंशंस और ओवरऑल डायमेंशंस निकाल रहे थे, तो उस टाइम आपने ऑलरेडी इसकी वैल्यू जो है वो कैलकुलेट करी होगी. Only thing in frame design, you have to calculate the value of A. and this value of A depends upon the dimensions of the core. Now, generally in case of a transformer, there are two types of cores available. One is called as square stepped core, and another one is called as three stepped core. क्वेश्चन इज, जब भी हम लोग अपने ट्रांसफार्मर की डिजाइनिंग करते हैं, जो उसकी कोर डिजाइन की जाती है, कोर जनरली दो तरह से डिजाइनिंग होती है, एक स्क्वायर स्टेप्ड कोर और दूसरा थ्री स्टेप्ड कोर. नाउ ये स्क्वायर स्टेप्ड कोर एंड थ्री स्टेप्ड कोर क्या होता है, दैट आई विल डिस्कस इन अनदर लेक्चर इन अ डिटेल, कि थ्री स्टेप कोर क्यों यूज करते हैं या टू स्टेप कोर यूज क्यों करते हैं, क्या एडवांटेजेस हैं, क्या डिसएडवांटेजेस, दैट आई विल डिस्कस इन सम थ्योरी पार्ट लेटर ऑन. But now for the design point of view, you must understand that whenever we can use a square stepped core, in that case your net iron area, that is AI, is equals to 0.45 d square, and your small a is equal to 0.71 d. But if you use a three-stepped core, in that case your net iron area AI is equal to 0.6 d square, and also in this case A is equal to 0.91 d. Now the question comes in the numerical, in the design problem, from the client side or from the design point of view side, it is clear that we are using a square stepped core and or we are using a three stepped core. For example, if we use a square stepped core, so in that case you had already calculated AI from the main dimensions. Substitute the value of AI from the main dimension into this formula. You can simply calculate here D, and this D is called as the diameter of circumscribing circle. After that, this D can be substituted in this equation, that is A is equal to 0.71 D. You can easily get the value of A and put this A value into this equation. D is equal to A plus WW. WW had already calculated in the main dimension. So from that you can calculate the value of capital D. Substitute the value of capital D and A. You can easily get the value of W, that is called as the length of the frame. Clear? But if in the numerical, if you use a three-stepped core, in that case your AI is equal to 0.6 d square. Again, this AI, that is net iron area, you can calculate it from the main dimensions of the magnetic frame. You can use that value, get the value of D again from the diameter of circumscribing circle. Substitute this diameter of circumscribing circle D here, get the value of A. Substitute this value A plus WW from the magnetic frame design. You can get a value of capital D. Again, substituting this capital D here and addition of this small a, you can get a value of W, and this W is called as the length of the frame. So here I can write down, substitute the value of A and D from the above equations. Depending upon which type of core you can use, the length of the frame W can be calculated. Clear? Anybody having any doubt up till this stage, he or she can ask me, otherwise I will start continuing. Yeah, anybody having any doubt?
No, sir.
Shall I continue?
Yes, sir.
Okay, fine. So once you can calculate the length of the frame from this equation, that is W is equal to D plus A, your second task will becomes, and the second task includes, you have to calculate the height of the frame. And this height of the frame is given by the relation, that is H is equals to HW plus 2HY, where this H is called as height of the frame, HW is called as height of the window, plus twice times height of the yoke. That is, height of the yoke is HY, and this HY is equals to gross core area upon A. Now again you can see from this equation that the gross core area, that is AGI, you can calculate it from the main dimension. So you can say that when you reach this step, when you have to calculate here, you have calculate the frame design, you are already calculating the gross core area. That gross core area is equal to AGI from the magnetic frame design. You are already calculating the value of A from the previous section, that depending upon the two-step core or a three-step core, depending upon if you use a two-step core, then you have already calculated the value of A, or if you have to calculate it, the three-step core, again you have to calculate the value of the A. Now you can simply divide the gross core area by this A, you can get a value of height of the yoke, that is HY. What we have to do, you can simply substitute the value of HW from the previous design, from the previous magnetic frame design, and your HY from this equation, you can easily calculate the value of height of the frame, and this height of the frame will be equals to H. So here I can write down, so by substitute the value of HW and 2HY, we can easily calculate the height of the frame. And as I had already told you, in case of frame design, we have to calculate the two important things here only. The number one will be the length of the frame, that is W, and second will be the height of the frame, that is H. So easily you can calculate the length of the frame as well as the height of the frame. I am just repeating once again that for designing of the frame, the most and most important thing you have to be remember that which type of core you can use. If you use a two-stepped core, in that case your net iron area has a different value, and if you use a three-stepped core, your net iron area has a different value. You can substitute accordingly. AI is equal to 0.45 d square or AI is equal to 0.65 d square. From both the relation you can get the value of the d, and this d is basically the diameter of circumscribing circle, and after that you can easily calculate the value of the A. And this A, when you substitute with your WW, you can get a value of D, that is capital D, that is called as the distance between the two core center. And when you substitute the value of D plus WW, you can get a value of length of the frame. And on the another hand, if you use a two-step core or a three-step core, so based upon, you will easily calculate the height of the yoke, that is HY, which is given by the gross core area upon the A. And after substituting this value, you can easily get the value of, simply you can say that give the value of HW as well as your WW, and you can easily get the value of the height of the frame as well as the length of the frame. So this is all about the frame design. In frame design, there are two important things, that is height of the frame as well as width of the frame. Clear? Now, I see Vinayak has certain question. Yeah, Vinayak, tell me what is the question?
Sir, is it applicable to both single and three-phase transformers?
Yeah, absolutely. Because you can say that if it is a single phase transformer, then the same formula will be using. If you can use a three-phase formula, then again the same formula can be using. But only difference you can say that that what type of, you can say that, a core you can use. If you use a two-stepped core, either in case of a single phase or a three-phase, or you can use a three-phase transformer, in again in that case what type of core you can use, either a two-step core or a three-step core. So it depends upon. So you can say that the height of the frame as well as the length of frame is only alter that what type of core you can use. It is irrespective that the transformer will be a single phase or a three-phase. I think now, Vinayak, your question can be cleared.
Yes, sir.
Okay, fine. So this is all about, you can say that the frame design. Clear? Now based upon that thing, what we have to do, we have to start our numerical. I can give you the numerical here, and you people start continuing it, and we will discuss one by one here. Okay, so the numerical for the today is, I cannot dictate all the theory, I can just simply put one numerical. You have to calculate the three main things in this numerical. you have to calculate the three main things. Number one will be the main dimensions, number two will be the winding design, and number three will be the frame design. That means in this numerical, what you have to do, you have to discuss all the things that we are discussing up till stage. Now, for calculating of the main dimensions, for calculating of the winding design, or for calculating the frame design, we are given a certain inputs from the client. And what are the inputs? That the transformer is designed having a capacity of 100 kVA. It is having a voltage of 2300/400 volt. It is a single phase transformer, shell type transformer, and you can use maximum flux density is 1.1 Weber per meter square. Current density is 2.2 amperes per mm square. Window space factor Kw is equal to 0.3. Separation of HW and WW, that is separation of height of the window to the width of the window, is 2.5. And one of the most important thing here, that the value of R is given, and the value of R is 480 into 10 to the power minus 8. So if you recall your memory, and you can see, I can tell you in my previous lecture, the very first step for designing of the main dimensions, you have to calculate ET, that is EMF per turn. And if you remember, the value of ET is equals to K under root Q. And the value of K you can assume from the table until and unless the value of R is not given to you, isn't it? Isn't it? Yeah, anybody?
Yes, sir.
So if I say if the value of R is given to the numerical, you can't assume the value of K. You can't use the value of K. In that case, you can substitute the value of R and get the value of K. Clear? So all the students to be present there, please tell me what is the value of K you are calculating. Now you will start calculating. After that, I will show you the next slide. Clear? So tell me what is the value of K you have calculated, because first of all we have to calculate the main dimension, and for main dimension the number one point will be we have calculated the value of ET, and for ET you have to calculate the value of K. Now the formula for the K I had already given to you. I'm not discussing here. You can get the value and tell me what value you can cover by the value of K. Tell me what is the value of K. So what is the value of K?
1.032.
Anhar, what is the value?
1.0322.
That means 1.0322. Now I will show you what is the value. Here is the main dimensions. Here is all the given that we have given. Now I can use the value K is equal to under root of 4.44 into F into R into 10 raised to power 3. So from that relation, yeah, exactly. The value of K is 1.0323. It is clear?
Sir,
Yeah.
sir, but frequency is not given in the question.
But if the frequency is not even given in the question, you have always assumed the frequency will be 50 hertz. Na? Because in an AC, there is always, we are using a frequency of 50 hertz. So it is understood. It is given or not given, you have to assume the frequency is equal to 50 hertz. In an AC supply, the frequency is always 50 hertz. So Manhar and Neha or Himanshi, value will be same. That is 1.032.
Yes, sir.
Clear? Anybody who got this value except from those who are already
Sir, 1.0322.
Absolutely right. Absolutely right. Vinayak, I had seen, you can see on the screen also. Clear, Ji? Now, what is the second step?
Yes,
What is the second step? You have to calculate the value of ET. That is EMF per turn. Now, tell me, what is the value of ET? You had a value K, you had a value of Q, substitute K and Q, get the value of ET. What is the value of ET?
10.32.
Kitna?
10.32.
Yeah, exactly. So ET is equal to 10.323 volt. Clear? Clear, जी?
सर हमें डेसिमल 3 प्लेसेस लेनी है या 2 ही लेनी है खाली?
वो ले सकते हो, बहुत है 2, अप टू 2 डेसिमल ठीक है, कोई इशू नहीं है.
ठीक है सर.
क्लियर है? समझ आ रहा है?
Yes, sir.
I think this approach will be right now. What do you say, Manhar and Vinayak and all that?
Yes, sir.
Yes, sir.
ये ठीक है टेक्निक?
Yes sir,
Yes,
yes sir,
sir.
बहुत अच्छी है.
चलिए नेक्स्ट, व्हाट इज द थर्ड स्टेप? AI?
Phi m.
Yeah, sorry,
Fine.
5m. So you can use the value ET is equal to 4.44 into F into 5m. Get the value of 5m. What is the value of 5m?
0.0465.
0.0464.
Absolutely right. Absolutely right. Your 5m will be 0.0465 ever. Clear?
Yes, sir.
Okay. What is the next step? After calculating the value of 5m, what is the next step? We have to calculate the value of AI, that is net,
AI.
that is AI is equal to 5m upon Bm. What is the value?
0.0422.
Yeah, absolutely. 0.04227 meters square. So you can say that up till that stage, you are proceeding towards the right approach. Fine. Fine. Shall I continue next? Okay.
Yes
After
sir.
the value of AI, we have to calculate the value of AGI. That is called as the gross core area. And the gross core area is AGI, which is equals to AI upon stacking factor. So what is the value?
0.0468.
Absolutely right. AGI is equal to 0.04696. Clear? Okay, bache? So after that, here I can substitute the last method in here, that is AY is equal to AGI into 1.1. ये last step था, लेकिन ये मैंने पहले ही कर दिया हुआ है. So your AY is equal to something 0.05166. Clear? So leave it that thing. Next will be. Okay, now I can substitute the as this value in output equation, that is Q is equal to, since it is a single phase transformer, so Q is equal to 2.22 into F into phi m into AW into KW into current density into 10 raised to power minus 3.
18 ही निकालना सर इसमें.
हाँ जी,
18 ही निकालना है इसमें.
निकालना है बेटा, निकालना है. You can calculate the value of 80. Okay, first of all, you can calculate the value of 80 because I had already calculated. You can calculate the value of 80 and tell me what is the value of 80.
9687.5.
This is the value 80. Now you can see on
Yes
the
sir. 96.
okay.
9687.5.
It doesn't matter. Doesn't matter. Clear?
Yes sir.
So after the value of 80, you have to calculate the value of AW, that is the window area, and you can use the window area from the equation, that is Q is equals to 2.22 into F into phi m into AW into KW into current density 10 raised to power minus 3. So you can see all these equations, that is we have 100, 2.22 into 50 into phi m, 0.0465 into AW, we have calculated KW,
Sir,
that is window space factor 0.3
there
into
is a
10 raised to minus 3. Yeah, Vinayak, tell me.
there is a slight change in the value. I have got 966.66.
नो इश्यू एट ऑल, नो इश्यू एट ऑल, चलेगा. बट ऐसा तो नहीं ना है कि मेरी वैल्यू 9685 आ रही है और आपकी वैल्यू कुछ 15,000 के करीब करीब आ रही है. सर्टन
No sir, no sir.
सर्टन वेरिएशन.
Only sir, slight
या
variation.
no issue at all. You can calculate the value of AW. So tell me either you can got this value or not. So are you getting this value or not? AW.
Yes, sir.
Okay, you can got this value now.
Yes, sir.
Okay, now what is the next step? Next step, you have to separate out AW in HW as well as WW. So from that relation, you can separate it. HW upon WW is equal to some value will be given to you. Okay, fine. So if you separate this value, so tell me what is HW and what is WW. In that case, the relation will be given to you, that is HW, that is the height of the window is equal to 2.5 times width of the window. So you can easily calculate the value of HW and WW. Tell me what is the value of HW and what is the value of WW. What is the value?
Mm,
Please repeat, Manhar.
WWRS है 0.10835.
0 point
10835.
सर सेम है.
same है. Okay. What is HW? What is HW? Height of the window.
0.2708.
Exactly. मेरे साथ match कर रहा है आपका. So up till that stage, you can cover the value of HW. You can cover the value of WW. So only one thing that you are left, it is height of the yoke. That is AY. What is the value of AI? AY. AY is equal to 1.1 AGI. So tell me what is the value of AY?
Zero point 05148.
Exactly. Clear? So after
Yes, sir.
calculating the all the dimension, and these all dimensions are under the category of the main dimensions or a magnetic frame dimensions or a overall design. So this is the worst part or the first part that we had covered. We have to calculate the main dimension. Now proceeding towards the second part, we have to calculate the winding detail. Now for the winding detail, you remember your first step will be, we have to calculate the number of turns on the low voltage side, and the formula will be voltage on the low voltage side upon ET. So tell me, what is the value of TLV? What is the value of TLV? That is turns on low voltage side. कितना आता है जी?
$38.74.
How much is the value of TLV? Turns on the low voltage side?
39.
Exactly.
38.74.
या मनहर, I will tell you कि कभी भी turns को जो
39 आएगा.
fraction में नहीं
Yes, sir,
लेना,
yes.
it will be taken on the higher side. So what is the value? See, 38.74. I can take it this as 39. Clear?
Yes, sir.
Okay, the next step will be, you have to calculate the number of turns on the high voltage side, and for calculating the number of the turns on the high voltage side, you can use the formula, that is turns ratio VLV upon VHV is equal to TLV upon THV. So what is the value? What is the value?
225.
225.
225.
So I got 224 exactly here. No issue at all. You can take a 225. No issue at all. Okay. So next step, you have to calculate current on the low voltage side, and the formula for the current on the low voltage side will be Q on VLV. But here you can turn this Q into 10 raised to power 3. So tell me, what is the value of current on the low voltage side? Tell me, what is the value of the current on the low voltage side? Hanji? How much is the value? 250 amperes. Absolutely right. So current on the low voltage side will be 250 amperes. And similarly, you have to, similarly you have to calculate the current on the high voltage.
43.47.
Yeah, how much is the value? Current on the high voltage side will be at 43.478. Clear?
Yes, sir.
Clear, beta? after that, what we have to do, we have to calculate the area of the low voltage side as well as the area of the high voltage side. Now tell me what is the value area of the low voltage and what is the area of the high voltage. So area of the low voltage will be ILV upon current density, and after that you have the value.
One 3.63.
Absolutely right. And what is the area of the high voltage side? That is again current on the that side and on current density. What is the value? It got 19.762, isn't it?
18.75.
Okay. So you can see both the areas of the winding are greater than 5 mm square. So we can use which type of conductor we can choose? We can choose a rectangular conductor on both sides, right? Because the area is greater than 5 mm square. Clear? So this is all about we have the main dimensions or the overall dimensions or the magnetic frame design, and also we have here the winding detail design. Clear? So in next lecture we will continue the same numerical and discuss how the frame design can be calculated. Clear, Z?